Of course, want to thank everybody who's listening to this session, whether you are listening in right now live or listening to this after it has been recorded. We always appreciate everybody who joins in and gives a little bit of a listen in. Today, as mentioned, we actually have one of our own team members, Joe, as well as a member from the SubQuery team, James, who is actually the COO of SubQuery. And I myself am, most people in the community know me as Atari Buzzkill, or John is my actual name. And yeah, hopefully I was going to give you guys the opportunity to present yourselves and kind of give an explanation to the community as the work that you're involved with and how you kind of ended up where you are right now. And I'll start with you, Joe, if you are ready to do so.
Sure. Hey guys, I'm Joe Sumner. I've been working as a software engineer at Fetch now since about the summer, and work on the indexer really just started as I was joining. So most of my time has been spent developing and testing the indexer, and yeah, I'm really proud to see how far it's come in that time, with some applications already being sort of facilitated by the data we've been collating. So yeah, really good on my end as well. Thanks.
Awesome. Yeah, thank you so much. And of course, James, you can introduce yourself to the community and get them to know you a little bit better.
Yeah, hey guys, I'm James Bailey. I apologize in advance for my terrible accent. I'm from New Zealand. We kind of tend to mumble everything we say, so apologies in advance if you don't quite get what I say. I kind of work at a team called SubQuery, which is a general purpose indexer that we just joined the Fetch ecosystem. We're going to talk about that soon. I work in the operations side there, but my background, I used to kind of work as a software dev and work my way into kind of product management and kind of ended up just doing whatever I could do at the time to make things faster and better for the team. So it's a bit of a weird role, but it's a fun one in the end. We've got a small team down here in New Zealand. It's kind of weird that we kind of work in the same office in Web3. It's an odd one, but I enjoy. I've been in crypto since like on and off since 2019, and it's been a fun time the whole way through. Even now, it's quite great. This like bear cycle that we're in, it means we can kind of just stop and take things a bit slower and more sustainably. The bull cycles last year and the year before were pretty crazy. So fun time in crypto. There's no quiet day and no boring day in this industry.
Awesome. Yeah, thank you so much. And for sure, I completely agree. There's definitely no boring days here. Even if not everything or all of your thought process end up getting, posted out there publicly, it's usually always behind the scene. There's some kind of new thing that you're either having to explore or, just topic that's being discussed within the ecosystem that's interesting. And yeah, it's very cool. I'm happy that you guys at SubQuery kind of saw the Cosmos ecosystem as an opportunity to continue to expand into, and I'm happy that we at Fetch AI are able to be a part of that because yeah, it's been good as Joe has said. And one of the things that I actually wanted to also allow you, of course, James, to be able to discuss here is when we first kind of announced the partnership that we would have between Fetch AI, we had kind of, I guess, to try and simplify the understanding a little bit of what SubQuery was and what it offered. We kind of described it as being similar to the effect of how like Google translates or indexes, web search results based off of things that you're trying to figure out. SubQuery kind of does this, but in a decentralized fashion, specifically for data indexing for blockchain developers for essentially those specific use cases. But is there, I guess, even a way that you like to describe SubQuery as, or how would you describe SubQuery, and who do you think that overall it best benefits?
Yeah, and Joe, pitch in here. Maybe I'll try to start with explaining what is indexing, because there's a term that is quite bespoke or technically kind of grounded. So data indexing, when let's say you're building an application on Fetch, um, one of the problems with blockchains, and this is a problem with blockchains across the industry. It's not just Fetch or Cosmos. It's every blockchain. Blockchains are essentially a series of data linked in blocks. So they're kind of a linked list. Every few seconds, a block is made, and that block includes the data or the events that have happened in the past X seconds. By storing data in this way, it's great to kind of like it makes it easy to kind of verify the completeness of the data and the integrity of the data, which is great for blockchains. But it's really bad when you're trying to access that data to use later on in an application. So, for example, if you're asking a question like, tell me, like this is a very simple example, right, that everyone's kind of understood, which is like a wallet example. So a wallet needs to be able to say, or show a user a list of the last, let's say, 10 transactions that they've made on that blockchain. They want to show an ordered list of the last 10 transactions that you've made. So you've got some transaction history in that wallet. Asking a blockchain that directly is actually kind of really tricky. It's really hard because you can't really ask a blockchain, what are those last 10 transactions? You have to kind of search through every single block individually and ask, is there a transaction from this account? There's a block. No, move on. Is there a transaction in this block for this account? No. And so forth. And you kind of have to go traverse back through the blockchain, block by block, looking for those transactions. Now that's a very simple example, but it applies to like everything else. If you want to see like time series histories, if you want to see like historic information, if you want to aggregate data that kind of spans time and block space, it makes things very inefficient when you're querying a blockchain directly, as well as blockchain isn't kind of optimized for queries. It's optimized for consensus and making sure the chain never stalls and so forth, right? It's not, these nodes aren't really optimized for fast read speeds for applications that support hundreds of thousands of users and so forth. So the way that we've got around this and the way that we're trying to solve this is by building indexes. And indexing is a technical process or a term that describes the process of looking and analyzing a blockchain in near real time. And every time a new block is added, you kind of pull off the data that you want. Now that might be all the data. You might index everything, but in many cases, to keep things more efficient and optimize, you might index just the information you want. So you could build an index that indexes, in the previous example, just transactions. And so every time there's a block added, you look for all kind of transactions or transfers, and you would index those into a data set. And a common example of a data set you'd index those to is a database. Now, the process of indexing is like taking data from a linked list or a blockchain and putting it into like a spreadsheet, right? If a spreadsheet or a database, you can sort, you can filter, you can search columns and stuff. It's a lot more efficient, right? We spent the last 30 or 40 years optimizing the performance of databases. And that's kind of what SubQuery does in a nutshell. It's an open source tool, and that allows anyone to do this, to Fetch and to every other Cosmos chain and to many other chains out there. We kind of support and focus on non-EVM chains. So we kind of support, for example, Cosmos, Algorand, Polkadot, Avalanche, Near, and a few others. So we're working on all these other chains at the moment as well. And you can index that data into whatever data set you want. And it's kind of flexible and open for you to use however you want. So if you're building your own custom application, your own custom UI, you can index custom data in a way bespoke to your application. Now you might say, well, hey, there's lots of API endpoints, right? Like a lot of networks have these support by these providers, and they provide these off-the-shelf API networks. And that's absolutely true. And I think that's something that Joe's kind of working on at Fetch. But if you're building a custom application that is kind of unique or is better than the competition, a custom application that provides a unique user experience, sometimes you need to take it a bit further. You need your own indexer. You need your own unique way to index that information so that you can provide a better experience than your competition. And that's what we kind of specialize in SubQuery is the unique, weird, and wonderful indexing. It's completely open, it's completely flexible, and we make sure it's fast and, of course, feature rich. So it's the best experience possible. Joe, did I give a good explanation of indexing? Did I miss anything? Did I kind of?
No, I think you covered things pretty well. Yeah, I've personally had a great experience developing with SubQuery, so yeah, my hat's off to you guys, really.
Awesome. So yeah, that's indexing in a nutshell.
All right, awesome. And yeah, actually, I was gonna just also kind of hand this over to you, Joe, so that you kind of have an opportunity, I guess, from Fetch AI's perspective of what we've actually been using the subquery-based indexer for, and you know the features and stuff, I guess, that have come most in handy from the like Fetch AI perspective.
Sure. So I guess I'll go through some of the things that have been developed over the past sort of 6 months, and some things we have in future as well, using subquery. So I would say that the indexer repository docs would probably be the best place to familiarize yourself with how far their indexer has come and what it's capable as of now. And you'll see it's completely dependent on subquery. There's a link to a sandbox located in the indexer induction documentation that will allow you to carry out all sorts of queries and to test it out for yourself on the mainnet and Dorado testnets. Um, as to the current state of these deployments, you can carry out sort of precursory searches for every transaction filtered by a certain amount or ordered by a certain amount, or even blocks by height, events by type, for example. And although we're capturing and storing a multitude of these primitive entities and others, we realized that if you wanted to search for every time a contract has been stored, for instance, you'd have to sift through each and every associated event or message and extract the data in full, and probably reassemble it in a more readable way, like much as sort of James says, it's incredibly impractical to have vast amounts of data without any way to sort of sort it. Instead, the bulk of the development has gone into carefully constructing more complex entities, such as store contract messages, contract execution messages, governance proposal votes, and delegated reward claims. All of which will be available very soon. So go ahead, start the repo, keep an eye on it, and I promise there's a lot more on the way with that one. And I would say in future, we're not only consolidating our list of useful entities, but some more experimental features are in the pipelines as well. For instance, we've been playing with the contract entity, providing it what we call an interface field, which can be filled in by detecting instantiation and execution messages of the contract, and then observing their characteristics in order to provide a level of confidence that a contract entity represents a certain type or interface, for example. A good example of this would be if 100 people instantiate the CW20 base contract, interact with it, create their own coins, etc. We can observe all of those messages, link them to one instance of this stored contract entity, and begin to build a picture of what we assume this contract does or represents within an associated sort of confidence level. So there's some really quite complex things we can do, all based off of the sort of basic building blocks that have been provided by subquery. And yeah, it's been really interesting to see how it sort of plays out, and I hope you guys keep an eye out for what's to come. Yeah.
The Fetch team have done a fantastic job. Their subquery project is a real work of art. It kind of covers a lot of stuff.
Yeah,
And it kind of really makes use of all the great features. It's really cool to see, and it really makes our team quite proud when we kind of see these projects out there by other teams. Because at subquery we don't really build an open source SDK, right? We build like the tool. We build in a hammock, right? We don't really kind of build the house from the hammock. But every so often we see some amazing projects being built using our tools. And so it really kind of makes things worth it for us. But yeah, no, they've done a fantastic job. And the best thing is like that project that Joe mentioned is open source, right? So you can download it from GitHub. You can read the docs,
yeah,
see how it works. You
absolutely.
can
Yeah.
go and you can go and extend it, right? If you want to kind of do something else or like adapt it somewhat, you can do that very, very easily. That's kind of the beauty of it.
Yeah, absolutely. Feel free to fork it, play around with it, whatever you'd like to do. Yeah, put in your own issues and stuff like that. If you would like to request anything, yeah, we're all ears for you guys.
And for like those that, so just maybe a bit more clarity around how it works, right? So it's basically written in kind of in TypeScript, very easy to use and develop on. It defines a few kind of key events that you look for in the chain that are trigger points. And we define like the shape of the resulting data. So the way that data is stored in the database, and the query interface is all defined in GraphQL. So when you run this, you can get a GraphQL endpoint. And if you haven't used GraphQL before, it's kind of very similar to SQL, but it's kind of safe to do over web requests. And you can make some pretty cool requests for GraphQL to kind of join these different tables up, join these different entities, search and sort, filter them, and then make this request from a client, any client you want, a website and mobile app. Potentially, we've worked for Oracle, so you can kind of get that data back on chain, that aggregated information. Anything like that. It's quite flexible.
Yeah, and just to build on what James says there, I think that's where the sort of power of it really comes, is that you can assemble these incredibly complex queries, and have another application do this, on a larger scale, and sort of build an application on top of this and be served this, quickly accessible data in large quantities. So it's really quite a powerful tool. Yeah.
Yeah, I mean, it sounds honestly like something that's really helpful. It sounds like something as well that could be very easily like overlooked of not like a thing that maybe other people would necessarily immediately think to, try and see if something like this existed. Because, I mean, it kind of does sound like that without access to something like SubQuery, or, just in general, the SubQuery based indexer that like, we've got, it kind of sounds like access to a lot of information would otherwise be such a pain that you would probably just kind of give up on it. So it seems pretty interesting, that this not only is kind of simplifying access like to information and to like data points, but it also helps in providing like actual clarity and connecting the dots a bit better, that otherwise would have kind of felt a little bit more static and out there to the point where you might not even look into it. Or looking into it would have been a massive pain. So that's really awesome. And I guess that pretty much actually one of the things I was going to ask originally was going to be, how SubQuery improved access to this information, but you guys have definitely covered that pretty well. And I guess because of that, I wanted to hand to you, James, to see if there was any ways that, automation potentially, like an automation use case, that you see possible out of using something like SubQuery.
Yeah, so that's a great question. It's something that we're seeing a lot kind of come through, right? There's this recent trend, I know that Fetch is kind of looking into and taking advantage of this, obviously of the kind of the automation, the AI kind of aspect, because blockchains haven't really done well at that in the past. The past 5 years. In fact, like a very simple example is like making a scheduled future transaction is still kind of like really, really difficult. And blockchains don't really get up for that. Or making a transaction like if this, then that. This is kind of a new kind of place that we haven't really seen a lot in. And I know that's kind of something that Fetch is delving into. So SubQuery is great when you want to like bring in data. So a lot of people often conflate indexes with oracles, and it's a simple mistake. They're kind of the opposite, actually. What an indexer does is it takes on-chain data and makes it and orders it more better for off-chain uses. An oracle would take off-chain data like price feeds from the real world. That's the most common use case, or like weather feeds from the real world, and bring that back on-chain into kind of smart contracts, so you can do stuff, you can automate stuff on the blockchain. You can access them from your applications, your decentralized applications on chain. Now, one thing that we're looking at with SubQuery, and we've started doing some work with some oracles on this, is mapping those together. So combining forces with an oracle, where you could, for example, you could index information on the chain. So let's say you want to wait till, let's say you've got a DeFi chain, and there are many DeFi chains in the Cosmos zone, or the Cosmos Cosmoverse. And you want to wait till a certain class of asset exceeds a certain price volatility, or the size of the pool exceeds some parameter. SubQuery can obviously index that information. Every block it can calculate that kind of derived value. It can update it, and as soon as something happens, it could feed the information back to a chain like Fetch via an oracle, to which you can then automate some action within Fetch to result from that. So, for example, if the price reaches a certain bound, you could automate a trade. If the level of liquidity reaches a certain parameter, you could potentially withdraw your assets from that pool because it's not liquid enough for your comfort margins. And this is the kind of thing that we're working with some oracles on, and being able to do that or provide that information back to contracts on chain. And that's kind of an example use case I'm kind of keen to see coming through with automation chains like Fetch in the coming years or months even.
Yeah, that's it's actually interesting that you talk about that because we actually even had done a little bit of I guess there was an application. It was slightly like a test run, but also like a legitimate test of, and people could use it and access it, where we actually had agents doing a similar kind of task there, actually funny enough, because what you're describing does sound a lot like essentially like DeFi, like stop loss, slash, you could even, consider other features and stuff as well.
Exactly. You can take this like all the way through, right? Those are the very
Oh
basic
yeah.
use cases and examples.
So it's extremely interesting because I do think that a lot of automation tools are extremely necessary, but it's just a matter of actually getting to that point where they exist. Because I think that that's kind of where in the DeFi space and even outside of just DeFi, just in the crypto space in general, when you look at, centralized exchanges or other things that they offer, often, things like this are very commonplace because it's just like an internal, system that they use and they have access to. And coming up with decentralized versions of these things that not only still keep users protected, but aren't also just like, basically giving away users, full identity and everything like that along with it, I think is definitely something that's being heavily requested by a lot of people, and also something that, I do believe that we'll see a lot more of in the coming year or so, because it's definitely people want to have access to the same type of tooling that you find. Like that's going to be the way that people go from, centralized services to decentralized ones, is once we get to the point where a decentralized service feels no different than the ease of use of those centralized services.
Exactly right. And that's kind of like the underlying goal of the last 2 or 3 years that we've been building SubQuery for. Like that is the kind of, and I believe you guys share that mission, right? Which is many people in this industry do, which is we need to get to a point where the user experience for these decentralized apps and these decentralized platforms is equivalent, if not better, than these centralized alternatives. Because we've seen some pretty, especially in the last 6 months, 8 months, we've seen some pretty tragic stuff happening with centralized services. And it's a constant reminder that, not your keys, not your not your coins, that kind of stuff. This is going to become more and more important into the future.
Yeah, 100%. I definitely agree with that. And actually, before we kind of get into the potential of going into any community questions, was there anything either of you guys, Joe or James, is there any other things that you found interesting, like, either like Joe working on building out the indexer or doing the testing? Was there anything that you wanted to share outside of that? Or are we okay to just move to community questions?
I think you're good to go ahead, really. I would just encourage everyone to, check out the repo, check out the docs. It's all there. There's plenty of help and information. And, if there's anything further, any examples or anything people are looking for, feel free to raise an issue, and we can take a look at it.
Yeah,
exactly
definitely.
right.
That's
And it never hurts just like ask like how like what's your advice or how might I kind of like index this information. I think Joe and I are very close to how it works, that we kind of very easily kind of give you a basic example of like you should index this, start by doing this, and write a function here that kind of changes that.
Yeah, absolutely.
yeah, for sure.
As I was saying, I mean, I've worked on nothing else for these past 6 months or so, so I'm very in touch with it. I'm happy to help as well.
Yeah, there's and just so that everybody is aware of how easy it would be for you guys to, get access to help if needed. On our GitHub, which is just Fetch AI, no spaces, no like period or anything in there, just like Fetch AI on GitHub. In the Ledger subquery repo, there is actually a discussion section, and in there you can you can post any discussions or questions, anything that you have about the indexer, and I'm sure that Joe or somebody else there will be able to kind of help you walk through that. Also, of course, you can submit any bugs or issues that you found on there to try and help, as this is an open source project, so you can contribute to this even as a community member or just developer who's messing around and has some spare time on your hands to try and aid in this. So, yeah, if that covers it for the main stuff that we wanted to kind of discuss to the community, I guess now is a good opportunity. If there is anybody who's listening in right now who has any questions for Joe or James in regards to the subquery indexer, then feel free to join in. I do know that this is a very dev-focused, heavy discussion, so it can be a little daunting. But don't be worried. There are no stupid questions. There are no anything like that. All questions are valuable. So, and if there happens to not be any questions in regards to that, which it is very much seeming like that is the case, which is come to be expected, as I said, I will assume then that you guys did such an amazing job at describing subquery and all of its functionalities that there are just simply no questions that could possibly exist. And so, yeah, I wanted to say, of course, thank you so much to you guys for coming on. Joe, I know this is your, I guess, first time kind of publicly appearing as a member of the Fetch team. So thank you for coming on. We're always appreciative when our like developers or engineers come in and actually kind of interact with the community a little bit and show yourself off. And of course, thank you so much to James, COO of SubQuery Network, for coming on and giving us an opportunity to speak with you and for you to speak with our community.
No, thank you very much for having me, and thanks Joe for joining us and working on subquery for these past months.
Yeah, of course, and thanks so much, John, as well, for having me. It's been good.
Yeah, awesome. Well, thank you everybody for listening in, whether you are listening in live right now or listening in after we have already had the session recorded at this point. We always enjoy that. And of course, if you guys ever have questions in the future that you want to ask, but you are not available for these Twitter Spaces sessions while they are live, don't be afraid that on the announcement tweets, you can always ask your questions there, and then I can answer them as the host. So yeah, never be afraid to ask questions prior to it. We always want to try and get to that stuff. So yeah, thank you everybody for listening in. As I said again, thank you Joe and James for joining us today. And I will see everybody from the Fetch AI community next week.